Hello, my name is Lucas Eichmeier, and in this part of low-temperature solar thermal power systems, we're going to speak about solar collectors. In principle, we can divide solar collectors by a multitude of different features. We can distinguish them depending on which working fluid they're going to use. Usually we use liquids such as water or air. We can also distinguish them by whether they are having some kind of glazing or not. You can have no glazing, a single window, or multiple glazings. Another distinctive criteria is the operating pressure. Solar collectors can operate at atmospheric pressure, slightly reduced pressure also at vacuum. We also can distinguish solar collectors based on the construction type. We have the flat plate collector and tubular collectors. I'm going to explain this in more detail in just a few minutes. And finally, we can distinguish solar collectors based on the absorber they use. We can have plastic absorbers, metallic absorbers, which are either selective or non-selective. We're going to speak about what a selective absorber is in one of the following videos. In this video, we're going to focus on solar collectors which use air, In this video, we're going to focus on solar collectors which use liquid as the heat transfer fluid. Commonly, there are 4 different solar collectors which are used. On the very top, to the left, we have the unglazed collector, which can operate only at very low temperatures. The flat plate collector on the top right can operate at slightly higher temperatures, and the vacuum tube collector can even produce higher outlet temperatures. And finally, we have the Sydney type collector, which is a double vacuum tube collector, which is able to operate at the highest operating temperatures. If we now have a look at the unglazed solar collector, we can see that this is a very simple system. As I said, it can only operate at very low temperatures, usually between 10 to 40 degrees C. And its operation is very strongly dependent on the ambient conditions. Unglazed solar collectors are often used for pool heating. If you now want to go to higher operating temperatures, we have to implement some kind of measures in order to decrease the heat losses. In order to do this, solar collectors often use some kind of glazing to reduce the heat losses. There are 2 typical solar collectors which use some kind of glazing. We have the flat plate collector on the left with the typical operation temperature between 20 and 80 degrees C. And we have the vacuum tube collector on the right, which uses evacuated tubes and therefore can operate at slightly higher operating temperatures between 70 and 120 degrees C. The flat plate collector, as I said, uses a single glass cover in order to reduce the thermal radiation and thermal convection losses to the front. It is therefore able to operate at higher temperatures in the order of 20 to 80 degrees C. The absorber used in the flat plate collector is either selective or non-selective. As I said before, we're going to speak in a future video about what a selective absorber is. In order to increase the operating temperature, so the outlet temperature of the fluid, to even higher temperatures, we can use evacuated tube collectors. These evacuated tubes, reduce the heat losses further and allow higher operating temperatures. The absorbers used in the vacuum tube collector can either be selective or non-selective. And there are usually 2 different types of operating principles. We have the direct or the heat pipe principle. There are 2 different principles of how evacuated tube collectors work. We have the direct principle, where the heat transfer fluid passes directly through the tubes. This results into higher efficiencies. The second principle is the heat pipe principle. Here, the heat is collected via a heat pipe. The heat exchange between the heat pipe and the main circuit happens in a heat exchanger, which introduces an additional heat resistance. This usually lowers the efficiency slightly. The advantage of the heat pipe principle, however, is that it's much easier to replace individual tubes. The vacuum tube collector is still a relatively simple system which allows relatively high operating temperatures. If we want to increase the operating temperature of the collector even further, we need to decrease the heat losses even more. In order to do so, the Sydney type evacuated tube is used. This solar collector operates with two concentric evacuated tubes. Usually, this evacuated tube has nowadays a market share of about 70%. Similar to the evacuated tube collector, the Sydney type collector also operates at two different principles. We have the direct principle and the heat pipe principle with the same advantages and disadvantages as the evacuated tube collector. In the slides, you can clearly see two concentric tubes. The inner tube in red, which is coated by a selective or non-selective coating, and the outer tube in red, in blue. In order to facilitate the heat transfer between the heat transfer fluid and the inner tube, fins are needed. Sydney type collectors are usually combined with a compound parabolic concentrator, a CPC, which increases the active area. The CPC concentrates the incoming solar radiation slightly onto the solar collector. Usually, CPCs are only used with Sydney type collectors as they can operate with higher operating temperatures. All other solar collectors would have too high heat losses. Thank you very much. This was low temperature solar thermal power systems, where we spoke about solar collectors. In the next video, we're going to speak about the collector physics.